Hi, thanks for joining us today. I'm Jessica Lyons, cybersecurity editor with the Register. I'm speaking with Jeff Huggins. He's president of Cailabs US, and today we're talking about securing global communications. Jeff, thanks for joining. So I understand in your previous roles that you have served as a Navy intel officer. You've also held some senior positions with some large defense companies. So tell us a little bit about your background.
So for most of my career, I've been trying to make communications happen, both starting as an intel officer in the Navy and then through various defense primes to make that happen. Most of it has been associated with RF, radio frequency communications, that work with satellites or point-to-point. Recently, I've joined Cailabs as the president of the U.S. Piece of Cailabs, and I guess I could say I've seen the light. The amount of data that comes down from RF has been a bottleneck for a long time. There's a lot of data out there that's moving around in space these days. There was a Starlink briefing that they gave back in January that talked about 42 petabits of data a day that they're handling in their network up in space. And there's a bottleneck to get it down to the ground via RF that only comes at 100 megabits. Recently, there's been some information about the undersea cables and the amount of data flowing through there. And the story all links together to be that there is just tons of data that's happening. And at some point, it moves from stuff that's nice to have to stuff that's essential to have and essential to national security or essential to the commerce going forward.
And as we see tons of data moving, this makes these an even more attractive target for cyber and physical threat actors. So I'm curious, what have you seen in terms of increasing threats and attacks against these?
Well, I mean, first off, the undersea cables in particular have been a commercial enterprise forever. And, you know, they've been doing a pretty good job of working through the ROI to make sure that they had redundancies to satisfy customer requirements. But as the infrastructure becomes more and more a necessity, both for commerce and for national security issues, there's probably an extra thought process that needs to go in beyond just the business sense on how these cables are structured and building in some resiliency and understanding and looking at it with eyes wide open on how things are unfolding and making sure that if there's a national security interest that maybe government needs to step in to augment it or guide things in a direction that's that protects that national security or brings that element into it beyond just a business case.
And what is being done right now in terms of securing the infrastructure, building in this resiliency, and how's that working?
Well, I mean, they've taken a number of initiatives, all just tied to the undersea cables. One of the things is there's a congressionally funded cable ship security program where they have a stipend for a couple of cable ships that are on call to be available to go into critical situations. I think the government is also, the U.S. government I'm talking about now, taking an interest in landing sites for these cables as they come into the U.S. to make sure that the connection is something that they have looked the risk assessment with and approved it or looked to or asking the businesses to do something a little different. Certain countries have the opportunity to create bottlenecks through their country or to create routings that more extensively than necessary go through their countries. Part of that is just inherent with the cables that and the places you have to connect. It dictates the geopolitical situation. I think the other thing that is now on the table is the technology associated with optical communications. As I mentioned in the opening, RF, radio frequency communication from satellites, was limited in speed to 100 megabits. And these cables are carrying things at 100 terabits or 200 terabits on the new modern ones. And you just can't get those speeds on RF to be a legitimate redundancy. But now that optical communications is available, that's something to consider. That optical speeds now are at 10 gigabits and moving on towards 1 terabit. So it's a legitimate redundancy or resiliency that's available that I think businesses are starting to look at from the business model, and governments can look at too from a sovereignty aspect.
So, yeah, I mean, when we're talking about global communications, it's obviously a really big issue here. So talk a little bit more. Is the technology with optical there? How widely adopted is it at the moment? And is this a viable solution?
I think yes is the answer, that it's a viable solution. In terms of adaptability, I go back to the briefing that Starlink gave back in January, where they talked about the number of connections and the number of optical terminals that they have up in space. I think somewhere over 7,000 optical terminals, communication terminals, is what they have on their satellites up in space. And they are connecting over 200,000 times per day between those optical communications to carry that 42 petabits of data that they have in their network. So the idea that optical is viable is absolutely there. The tough thing, I guess, that I recently is getting figured out is punching through the atmosphere. That the atmosphere interferes with scintillation, with weather, with other things that can interrupt that laser signal. In space, there's nothing to interrupt it. So what you send out from the satellite is what you receive at the satellite. And there's two technologies that have been maturing. One is adaptive optics concept, where you have a lens actually that you flex to get the best picture, and that's been in use for quite a number of years, and it's pretty effective with stars that are a long ways away. You look at the star and you flex the lens until you get the best picture. The other technology is MPLC, which is multiplane light conversion, where you basically gather all the light, divide it into 45 different modes, and then use some technology to reform that beam in exactly as it left the satellite. The technology is 8 or 9 years old, but it's pragmatic and working now. So there's two different ways to approach it that can get you through the atmosphere. That was the last piece, I think, in the optical technology, and it's there now. So going forward, I think that it can be add some resiliency to our global network.
Great. So tell me, what do you expect to see going forward? I mean, the issue of data, it's obviously not going to get any smaller. So
Right.
How do you see this playing out in the future?
Well, I think it's not being a fortune teller. Everybody that we talk to in the industry has had optical communications on their roadmap at some point. And it's just a matter of when do you do that? And I think that now is the when. And that's what people are doing. They're dipping their toe in and buying optical ground stations and installing, and Starlink in a big way has installed optical up in space. And so, what I foresee is over the next 5 to 10 years is when we're really going to see optical take off. And what that does by opening that big pipe, similar to what unfolded when we moved from dial-up on the internet to big data flows, that all sorts of possibilities for different apps and capabilities. People will start thinking in all sorts of different directions with a big pipe coming down from space that they hadn't been thinking about before. So, I think it's cliche to say that, big changes are going to happen. They've been happening for the last decade, and they'll continue to happen for the last decade, but for the next decade. But I think this will be a real game changer.
And one thing you mentioned, that everybody's had this on their roadmap. So I'm curious, what's been the holdup? Is it a cost issue? Is it the maturity of the technology? What's been the stumbling block to this point?
All of those things are part of the decision process for a business to move or a government to move forward with a new technology. And I think that a number of those boxes are now ticked. As I mentioned, punching through the atmosphere has been a challenge, and I think there's two technologies that are moving forward to fix that. The other is an adoption thing, and in that there's a lot of satellites up there that have just radio frequency links. So the satellites with optical links have to get launched and get up there in space, and they'll do that if they have assurances that there's a big network on the ground. And so right now we're in the process of developing that network on the ground, and people are in the process of sending up satellites that use optical communication terminals instead of RF. The trade-offs are that if you use just an optical communications terminal up in space, you have less power requirements, you have less weight requirements than you do with an RF transponder. But if there's not an optical ground station on the ground, you still need an RF. So anyway, that chicken and egg sort of thing is getting solved and moving forward. And so, I think things are going to go.
Great. Well, Jeff, we'll check back with you and see if your crystal ball was working correctly and see how it goes. Thank you so much for talking with us.
All right. Thank you.